Hello friends, welcome back to our channel. Today in part 6.3 of Mastering Parallel Programming series in C Sharp, we are diving into a specialized concurrent collection, the concurrent bag. We'll explore what a concurrent bag is and learn how and when to use it effectively in your C Sharp program. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. Parallel programming using PFX, that is Parallel Framework Extension Libraries in C Sharp. If you have been following along with my previous videos in this series, you might recognize this diagram. In our previous videos, we have covered PLINQ, that is Parallel LINQ, Parallel Class and Task Parallelism. Currently, we are learning concurrent collections. .NET Thread Safe Concurrent Collections. In our last video, we focused on Concurrent Qt and Concurrent Stack T. If you haven't watched it yet, I highly recommend checking it out. You can find the link to that video in the upper right hand corner of this video. Today, we will be discussing ConcurrentBag in detail with practical examples. Demystifying ConcurrentBag concurrent collection. So what is ConcurrentBag? ConcurrentBag T is a thread-safe unordered collection of objects with duplicates allowed that can be used to store and manage items in a concurrent environment. So where it is suitable? It's suitable for the scenario where we don't care which element we get when calling take or try take methods. Okay, so let's imagine you have a bunch of balls of different colors and you want to store them safely. So a concurrent bag in C Sharp is like a special bag that can hold these balls. What makes it special is that allows multiple people, or if you say in computer terms threads, to add or take balls out at the same time without causing any chaos and dropping any balls. So overall, ConcurrentBag is a safe and efficient way in C Sharp to manage a collection of items like balls when you have multiple things happening at once. That is, the multiple threads are trying to do some activity. So it ensures that everything remains organized and nothing gets lost, just like a well-managed bag of balls. Okay, so let's see how we implement it in C Sharp program. First of all, we need to create an instance of the concurrent bag to hold the ball. That's what we need to write, something like this. Concurrent bag string ball bag is equal to new concurrent bag string. Basically, I have created an instance of the concurrent bag of a string type. This is the instance variable name ball bag. Now, what I'm going to do, I'm just going to adding balls into concurrent bag. So how we can add it? We can add it with the help of add method of ConcurrentBag class. That's why we have used ballBag.add. Here I'm adding blue ball. Similarly, I have added red ball and green ball one by one. Then after adding those things, I want to know how many balls are there in the concurrent bag. So how we can know that? We can use the count properties of the concurrent bag. That's what I have written over here. BallBag.count. And what I'm doing in this statement, I'm just printing total balls in concurrent bag. And what is the count? Whatever the count of ball is there in this concurrent bag, that I'm just fetching it with the help of count properties of this concurrent bag class. That's what I have written ballBag.count. So this statement will print actual number of balls which is already available in the concurrent bag. What output would be? I have written output over here. Total balls in concurrent bag, which is nothing but the 3, because I have added 3 balls over here. 2 ball, red ball and green ball, right? After adding and after seeing the count, I'm just trying to show you how we can remove the balls from the concurrent bag. For that, what I have done, I have used this for loop. Here I have written in the for loop, int I is equal to 0, I is less than ballBag.count I plus plus. So here I am just using this try take method of this concurrent bag class. It will make sure that if the ball is available, then it is just going to get execute this statement. Otherwise, it's just returning the false value. So this if statement will not get executed. Instead, this else statement is going to get printed into console window. No more balls to consume. Okay, so now you must have an idea what concurrent bag is and basic working knowledge of it, right? So let's switch to the Visual Studio and see all these things in action. Okay, so here we are on Visual Studio. Here I'm going to show you demo of producer consumer scenario using concurrent bag as this head collection and SemaphoreSlim for synchronization purpose. So to show the demo, what I have done, I have created a console application named ConcurrentBag demo that has program.cs file. In program.cs file, first of all, I have added necessary namespaces like using system.collection.concurrent, using system.threading, using system.threading.task. Then there is a class named program that has main method, which is an entry point of this application. So in this main method, first of all, I'm just printing this statement. What I'm printing? Concurrent bag, concurrent collection demo. Then what I have done, I have created an instance of this concurrent bag class to hold the balls. That's what I have written this statement. Concurrent bag string, ball bag is equal to new concurrent bag string. And then I have created an instance of the SemaphoreSlim class. That's what I have written. SemaphoreSlim, semaphore is equal to new SemaphoreSlim 0. You must be thinking why I have used SemaphoreSlim over here. Because I want to coordinate between the producer and consumer, and SemaphoreSlim class help us to ensure that the consumer only tries to make items that have been added by the producer. Okay, then what I have done, I have created two local function, or we can say local methods. What I have created, producer method and consumer method. In producer method, what it does, it just going to add balls to the bag. So here if you notice, in producer method I have passed two parameters, string color, int count. Based on the count, for loop is going to iterate. Then what I'm doing, I'm just going to add the ball string into this concurrent bag, which is representing over here ball bag collection, right? So ball bag dot add ball. Then finally what I'm doing, I'm just printing into the console window what I have added. Produce, that is added, and whatever the ball I have added, I'm just going to print into this console window. And for each ball added, the semaphore is released to signal that item is available for consumption. That's what I have written this statement, semaphore.release. Basically, it's just going to signal the semaphore to indicate a new item has been added for consumption. Then what I'm doing, I'm just writing this statement, thread.sleep 100. Basically, what I'm doing, I'm just simulating some delay over here. Okay, now let's see the consumer method. What consumer method does? It just removes the balls from the concurrent bag. So here, I have written this for loop, and it is going to get executed based on whatever the input parameter for the count value we are receiving. Based on that, it will iterate that number of times. Now, I have issued this statement, semaphore.wait. What it does, it will wait until there is at least one item to consume. Next, if an item is available, what I'm going to do, I'm just going to remove and process. And if the ball is available, how I'm going to remove it? I'm just going to use this try take method. That's what I have written. If ballbag.try take out a string ball. It means if we are successful in order to move the ball from the concurrent bag, this method is going to return true value. So we will be able to remove and process that. Then control will come in this if block. Then this statement is going to get printed into console window. This statement is going to print consume, that is removed, and whatever the ball that we have taken out from the concurrent bag, it is going to get printed into console window. If ball is not available, it means ballbag.try take, it is going to return false value. So this else part is going to get executed. So this statement will get printed into console window. No more balls to consume. Then I have created task array that has 4 tasks. That's what I have written. Task array, task is equal to new task 4. First 2 tasks are the producer task. What are those tasks? Task 0 and task 1. That add 5 red ball and 5 blue ball respectively. The last 2 tasks are consumer tasks. That is task 2 and task 3. At each attempt to remove 3 balls. What I have written, consumer 3 over here. And here when we are going to add balls, I'm just going to call this producer method. And then I have issued this statement, task.wait all tasks. Basically this statement makes sure that it waits for all tasks to complete before proceed. Then finally, what I'm doing, I'm just displaying remaining balls in the bag. Before that, I'm just printing total balls remaining in the bag. I'm going to get it count properties of this concurrent bag class. That's what I have written, ballbag.count over here. Finally, I'm just printing remaining balls in the bag. For that, what I have done, I have used this for each loop. Basically, it will iterate this ball bag, that is the concurrent bag collection. Then just going to print whatever available in the concurrent bag. So that's how this program is constructed. Okay, so let me execute this program and show this outcome to you. Okay, so output got appear into this console, right? Concurrent bag, concurrent collection demo got printed, produced, added blue ball 1, produced, added red ball 1, consumed, that is removed, red ball 1, consumed, that is removed, blue ball 1, produced, that is added, blue ball 2. Basically this produce and consume operation got performed into this concurrent bag collection. If you notice, consume is going to happen when that ball is available, right? For example, blue ball 1 got added, red ball 1 got, so only these 2 balls can be removed from the concurrent bag. When this removal operation got performed, it is just removing this red ball 1 first time, then it got removed second blue ball 1, then producer is going to produced, that means added blue ball 2, red ball 2. Similarly, consumption is going to happen when this ball is available, red ball 2, blue ball 2. Then finally, what I'm doing, total balls remaining in the bag 4. You notice in this program, task 2 and task 3, where I have passed this consumer 3. But if you notice, I have added 10 balls into that concurrent bag. But I'm just going to remove this 6 balls. So task 2 is going to remove 3 balls. Task 3 is going to remove 3 balls. So basically, 6 ball is going to get removed out of 10 balls. So here 6 balls got removed, 4 balls is remaining. So that's what this statement got printed. Total balls remaining in the bag 4. What are those balls that I'm printing over here? Remaining balls in the bag: red ball 5, red ball 4, blue ball 5, blue ball 4. So overall you have seen this program demonstrates a basic producer-consumer pattern using ConcurrentBag and SemaphoreSlim. So producer, what it does, it add items to the ConcurrentBag and signal availability using semaphore. And consumer, what it does, it waits on the semaphores to ensure items are available before attempting to remove that item. So the coordination ensures that consumers only remove items that have been added, providing thread-safe way to manage concurrent access to the shared collection, which is nothing but the ConcurrentBag. Okay, so that brings me to end of my session today. To sum up, in this video, we learned what a ConcurrentBag is and how we can use it with SemaphoreSlim that ensures a thread-safe way to manage concurrent access to the shared location. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.